Okay, now you can refer to your module on page 35. This is about 2.4 inertia. Okay, let's look at some important facts. I hope you already watched the videos that sent to you and you have read all the notes regarding this topic. Okay, now we go through our module. Okay, number one, just a refresh for you all. What is the definition for inertia? So inertia is a natural tendency of an object to maintain a state of rest or to remain in uniform motion in a straight line. So it is not a physical quantity. It's a natural properties of an object. Number two, law of inertia is related to Newton's first law of motion, which states that an object will remain at rest or continue with a constant speed in a straight line if the external force acting on it is zero. No force act, no external force act on your object. So number three, relationship between mass and inertia. When mass increases, inertia increases, meaning the heavier object will have larger inertia. Right, number four, we have this device that we can use to study a relationship between mass and inertia. So we call it inertial balance. Okay, so it consists of what? So this one we call it inertial balance. It have the rack here. We can put a load like a metal cylinder, clamp it to the table, let it oscillate, then we record the time taken for 20 oscillation, let's say, and then we calculate the period of oscillation. An inertial balance is used to compare masses or to measure mass of an object. When the mass of the metal cylinder is increased by adding a second metal cylinder, the period of vibration becomes longer. Squared of period of vibration T squared of an inertial balance is directly proportional to the mass m of the metal cylinder. Meaning if you put more metal cylinder on the rack, then the time taken for 20 oscillation increases, or we can say period of oscillation increases. That's why we can get this relationship. When we plot a graph, we have, let's say we collect about 5 sets of data, increase the masses until 5 values of masses, then we can plot a graph of T squared against M. Then from the graph that we get, we can state the relationship between T squared and M as directly proportional, meaning the graph is straight line pass through the origin. Okay, this activity, I've sent you the videos on this topic about using a coin, a cardboard and a glass. If you observe what happened when the cardboard is pulled out quickly, you can see the coin suddenly drop into the glass. It does not go together with the cardboard. So we want to explain this situation by using the inertia concept. Look at how the explanation goes. Okay, observation, the coin drops vertically into the glass. Explanation, inertia of the coin causes it to remain at rest. The coin drops vertically into the glass due to its weight, meaning it does not move together with the cardboard but remain its state of rest, its original position, its original state of rest. Thus, it just dropped into the glass due to gravity pull or weight. Second example. Okay, so we have a stack of wooden block. What we do, we hit hard by using a ruler at the bottom part of the wooden block. Okay, so observation. The other blocks fall vertically onto the table, meaning only one that hit that able to move out from the stack of the wooden block, but the rest all still remains at that position. Okay, so explanation. Inertia of the wooden blocks causes them to remain at rest. The weight of the other blocks makes them fall vertically onto the table, meaning they have a inertia to remain in state of rest. Example 3. Now we have two pails. One filled with sand, the other one is empty. The pail filled with sand feels more difficult to move and to stop moving than the empty one. Okay, you try to move the two pails together. So we will find that the heavy one is difficult to move. And then if you try to stop it, the heavy one also is harder to stop. So explanation. The pail filled with sand has greater inertia or mass than the empty one. Okay, now look at this one. Justify the effect of inertia in daily lives. Okay, so some of the situation in daily lives happen under this concept of inertia. Okay, number 1, look at the situation. The passengers in the bus will jerk backward when the bus accelerates suddenly from the rest. Okay, start moving suddenly, start moving forward or accelerate forward. So what happened to the passengers? Jerk backward. So explanation. Inertia of the passengers makes them remain in their state of rest, their original position. Okay, number 2. The motorcyclist jerks forward when the motorcycle stops suddenly. So you want to explain using the concept of inertia. Inertia of the motorcyclist maintains his state of motion, moving with constant speed. Okay, meaning at first, the motorcyclist is moving forward, okay, with the motorcycle. Suddenly, when the motorcycle stops suddenly, inertia of his body still moving forward or maintain the motion forward. That's the reason why the motorcyclist thrown forward or jerks forward. Okay. The third situation, we have one car and a lorry or a truck. The moving truck is harder to stop compared to the moving car. Why? The truck has bigger mass, so inertia also bigger, meaning it will continue moving a few meters further compared to the car, even the brake is applied at the same time. Because the truck has larger mass, so it has larger inertia that maintain the motion forward. Okay, number 4. Tomato sauce is easier to pour by shaking the bottle and stopping it suddenly. Okay. Explanation. When you shake, meaning at first your action is bring the sauce and the bottle downwards, meaning the sauce and the bottle are moving downward together. Suddenly when the bottle stops, inertia of the sauce still remains in motion downward. Thus, the sauce will come out from the bottle. Right? So the inertia of the sauce will force it to continue its state of motion, thus flow out. Okay, so this one is situation. There are more situations. You can go and search in the internet and find another application. And I told you all to do the activity 2.9, so you can go and search for more application or for more situation regarding inertia. Okay, so when we talk about inertia, it can be beneficial, it can be harmful, it can give positive, it can give negative effect of inertia. Look at the first one. Number 1, 3 effects of positive inertia. A. drying off an umbrella by opening and closing it quickly. Or you can just rotate the umbrella and stop it suddenly, let it stop suddenly, so the water droplets will come out or remove from the surface of umbrella. To tighten a loose hammer, okay, so you just knock the handle downwards, knock to the table for example, the hammer head, which is heavier, still maintain its motion downward, thus tighten to the handle. See, a sumo wrestler who has greater mass also has greater inertia. He is harder to topple down. Okay. Number 3, the negative effect. Number 2, negative effect. It can be harmful. For example, during an accident, passengers are thrown forward when the car is suddenly stopped. A heavier vehicle will take longer time to stop. Bus passengers are thrust forward when the bus stops suddenly. Okay, so this is all about negative effects of inertia. As you can see, mostly happen during accident. Okay, so this is about inertia. So you can go and look more for some of the structured question and essay question at the end of this topic, so you can understand better this topic.